Hi there. Today we're going to talk about how you can find the area for a trapezoid. Yesterday we talked about triangles and parallelograms. A trapezoid, just like parallelograms, is a four-sided shape, and also like parallelograms, it has one pair of parallel sides. Just one pair for our trapezoid. That's what makes it different. You should have your formula sheet in front of you to follow along with as we go over today's notes. We're going to refer to it quite a bit. So to find the area or the space inside of our trapezoid, we're going to need to be given some measures. They're going to give you the measure of bases 1 and base 2. Now don't get kind of freaked out by the fact that there are two bases. The reason they have to give you the measures for both bases is because they're different. Because it's a trapezoid, we usually have a shorter, or we always have a shorter side or a shorter base and a longer base, just due to the nature of the shape. That's why you have to have the size of both, or the measure of both. You're also going to need to know the height in order to find the area for a trapezoid. Sometimes they put it on the outside of the trapezoid like they did in this example. But I could just as easily given you that dashed line that forms that perpendicular relationship with the base, just like with our parallelograms and our triangles. And that indicates that measure, usually notated by a dotted line, is the height. You always need to form that perpendicular relationship. So we have a handy dandy formula that we're going to use to find our area for our trapezoid. You're going to need to know the measure of base 1. So let's just make sure we know how to find these things. What's the measure of base 1? Well, the arrow is pointing to 10 feet. So 10 feet is a measure of base 1. Base 2 has a measure of 14 feet, and our height, of course, has a measure of 12 feet. Make sure you have that perpendicular height. They might try to throw you off by giving you some extra measure of this side. Let's say I just threw 13 feet in there, but that would be the slant height, or the slant. It measures the slant along that trapezoid. We're not interested in that. Remember, we want that perpendicular right angle relationship between our base and our height in order to use it in this formula. And that is 12 feet. So let's look at the formula. Here it is. Looks very similar to our triangles. Remember, our triangles were 1/2 the base times the height. Now, because it's a trapezoid and you don't have one base, you have two bases, those two sides that are parallel to each other. So to work with this formula with trapezoids, which is just a little different from our triangles, we're going to have to take one base, add it to the length of the other base, because they're two different sizes. One is shorter, one is longer. Multiply that by the height. And then lastly, divide that measure by 2, or if you prefer, multiply it by 0.5, which is the decimal equivalent for 2. A in our formula, of course, means the area. B1 is just the first measure of the first base. B2 is the measure of the second base, just like in baseball, huh? And then H for our height in our formula. So let's look at an example. Here we have a trapezoid. We have one side of parallel sides. Remember our parallel sides, those are going to make up our bases. Base 1, just because it's the first one, that's why I labeled it base 1. Base 2 because it's the second one, looking from top to bottom. Our height that they give us is 9 feet. Just want to be sure you know that sometimes we put the height on the inside of the shape. Sometimes we put it on the outside. No matter where it is, as long as we're forming that right angle, that 90-degree perpendicular relationship with the base, it is the one that we want for our formula. So we're going to plug in our formula, which you never have to memorize. They're always going to give it to you on a formula sheet. Find the picture of the trapezoid. Use that formula for area. Plug in the values into your formula. So our first base, we just called it the first one because my eyes landed there first. The measure of that is 8. You really don't need this now. And then the measure of our second base was 10. You really don't need that. You're not going to raise it to a power or anything. I'm just showing you that was the measure of the first base. 10 is the measure of the second base. Order of operations say, do what's inside of your parentheses first. So we're going to add 8 plus 10, which of course is 18. And in the order from left to right, I've got multiplication here and multiplication here. Let's do it in order from left to right. You may turn that fraction into a decimal and take 0.5, multiply it by 9. 0.5 times 9 is 4.5. And then our last step is to take 4.5 and multiply it by 18, which I'm going to let you do. This would be a good place to hit pause. Okay, and 4.5 times 18 is 81 square feet. And that would be our measure for this trapezoid. Let's look at our next example. What I love about math is once you get a formula that works, it always works for every shape. Here's another trapezoid. Like I said last time, I could have just as easily put the height on the inside of the trapezoid. But if it's 7 inches out here, it's 7 inches in here as well. I know how to find my bases because those are the sides that are parallel to each other. 4 inches and 6 inches, those sides are parallel. They're never going to cross. I just call it 4 inches my base 1 because my eyes landed there first. And 6 inches is going to be my base 2. Plug them into our handy dandy formula. All right, so our height, I had to fix that mistake, is 7 inches. So order of operations say we have to first find half of 7. And if you want to turn that fraction into 0.5, the reason I'm using 1/2 is because I want it to be identical to what you're going to see on your formula sheet. And half of 7 is 3.5, and of course 3.5 times 10 is 35 square inches. All right, so for the next few examples, I'd like for you to use the pause button on these videos to work ahead, and we will check as we're looking at these examples. Don't want you just to record them. I want you to get in some practice. Here's our next trapezoid. Again, I just want to reiterate, I could have just as easily drawn that height inside the shape. They chose to pull it out of the shape. And when we take our formula and plug in our height and our base 1, our base 2, again, I just do what makes sense to me. Makes sense to make this the first base because it's up top and this to make the second base because it's on the bottom. But you could do it differently. Order of operations say, take care of what's in the parentheses first. Please hit pause and complete this. Okay, so 11 plus 5, of course, is 16. And we're going to multiply in order from left to right. You can turn 1/2 into a decimal if you prefer to do it that way because it's more calculator friendly. You should have gotten a solution of 64 square meters. Let's look at another one. This time they did pull that height into the trapezoid. You're going to look for that 90-degree relationship. We've got two bases. We know which are the bases because they're parallel to each other. That answer came in too soon. Let's pull it out. Go ahead and use your formula to solve this question. Okay, so we've got our formula 1/2 times the height plus the sum of base 1 and base 2. Order of operations say add. So we're going to add. And this probably would be a good time to use that 0.5 equivalent for 1/2. And we're going to work that in order from left to right. And then you get the area of 38 and 425 thousandths square meters. And then lastly, here's our trapezoid with the measures given. Always look for those pair of parallel sides to determine which is your base 1 and your base 2. Plug them into your handy dandy formula. Use your order of operations to solve. Doing that addition first. And then in order from left to right, again, you can turn this into 0.5 if you want. You should get a area of 110 and 55/100 square centimeters. Thank you for tuning in to your notes on trapezoids. Look forward to seeing you tomorrow.